Okay. Good morning, everyone. It is a pleasure to welcome everyone to this session of SpaceGeekSpeak. SpaceGeekSpeak is sponsored by AIAA Houston section, and we hold our meetings every Saturday at this hour. Anyone is welcome to speak. We have dedicated speakers, and on other times we have a free-form discussion. Today we have a pleasure of Andre Duele to present information on newly released standard by AIAA and ANSI as defining human spaceflight as spacecraft ontology from architectural and system engineering viewpoints. Andre is a chair and co-founder. Andre is a chair and co-founder of Space Architecture Committee on Standards, has background in our architecture, human-centered design, and system engineering. He is part of the Artemis team supporting development of orbital and lunar surface systems as a senior human factors engineer. Andre, thank you for coming and welcome. This is your floor.
Thank you very much, Svetlana, for the introduction. I just, can you confirm you can hear me?
Yes, here, clear.
Okay, perfect. Okay, so thank you for the invitation as well. So I will present the, let's say, overview of this standard, because the standard itself or its contents cannot be presented due to the copyright. So this is a little bit tricky presentation, but I try to touch all the points I can and provide you with a couple of, let's say, teasers, if you can call it in standard at all. But first of all, a little bit of intro also about me. So I'm involved in this beautiful module you can see on the top right side, which is a Halo core module for the gateway station. And it kind of fills into or fits into this ontology as well quite well. Should it be classified? In hopefully 2-3 years, this first module with the power and propulsion module will be orbiting the moon as a foundation stone for the lunar orbital station. So just a little bit of sidetrack, but let's get to the standard itself. So this is a document or product that has been developed by Space Architecture Committee on Standards together with support of Space Architecture Technical Committee and System Engineering Committee. So what you see here on this slide, you see the list of subject matter experts who are contributing to this document and followed up for quite a long period of time with me, and I really appreciate that. I appreciate the patience in the first place. The standard was actually, the committee was established by Fred Slane, who was an actual member of SATC a couple of years ago. And I got in touch with him during the 2018 year, where the environment was, let's say, kind of fertile for this sort of activities, and we were all seeking some type of framework. So together we co-founded the committee, we saw the subject matter experts, and on September 27, 2018, we shared the letter of intent with AIAA, and then we went through the establishment process, which took a couple of months. I believe it was like 4 months to just establish the committee. The goal of the committee was to first draft this, let's say, abstract content to this to this standard, which was supposed to focus on the architecture organizational system. And that's very broad scope. If you talk about architecture, everyone has different approach to architecture. Everyone has different definition of architecture. And therefore, especially in space and specifically in space, we wanted to find a common denominators, common structure, common types, common vehicles, common nomenclature. And this is quite difficult. And therefore, I'm kind of really happy that we got to this point. Although I'm expecting that the standard will see a lot of revisions, I'm really glad that we got to the point that we were approved and published. So the S-153-2021 is a first level standard. What does it mean? It means that it's a governing standard. That means that it provides or describes the environment where other level standards, let's say second, third, fourth level standards should be fitting in. And again, it is expected that it may be tweaked, slightly modified. The nomenclature may be changed based on what the industry or government needs. So as we know, ANSI and AIAA standards are not binding, they are guiding, but it really depends on the organizational characteristics or on the contract, for example, you're dealing with. It can be contractually binding, specific to certain projects. 3-level standard. So the first level standard is a governing standard. So it describes where the other standards should fit, what the other standards should define. In our case, we call this standard ontological because it defines objects, relationships, and the environment for the other standards and the environment of the actual topics we are describing. So here you see a couple of synonyms: framework, typological framework, nomenclature, taxonomy. All these themes are attempted to be covered in this standard, and in a way or in a manner that is as user-friendly as possible. That's another way to look at it, that we really don't try to be extremely complicated, but we try to have a practical impact on the human spaceflight domain. So the terminology we are using, we are trying to, let's say, normalize in good sense for interdisciplinary audience, and that means, or what we have identified first, and you may have the similar experience, that different engineering disciplines are using different terms, and specifically in architecture areas, architecture of different systems. So, and I'm gonna touch that a little bit. This is gonna be a little excerpt from the standard in terms of terminology, because we found it the most important. The core of the standard itself is actually shorter than the terminology. And further on, it should be a guide to other standards and design processes. This is one of the most important, let's say, outcomes or outputs of this standard, that it provides a framework that would guide you, or that will guide you, to existing standards and processes based on what type of vessel or vehicle you are expected to work on. So it should be practically used as a handbook. Currently there is, though, almost no guiding content. It's currently only a framework. So we are waiting for other communities, industry, other standard organizations to populate these standards, so we can fill up this standard with the other standards, as well as our committee that intends or is discussing currently in which direction we should go and which standard, level 2 standard would be, for example, most important. Now the levels, the description of the levels, that's also the content of the standard. What I can say here is that the second level is focusing on specific vehicles, meaning, for example, space tourism vehicle or vehicle for mining purposes. So this standard is defining these categories and is attempting to kind of lead this typology forward. The standard was approved by ANSI and AIAA in April 2021 and was published later in May 2021. It's currently available for purchase on ANSI AIAA websites. I believe for non-members it is $19. It costs $19. And this is direct quote from the standard. I will skip the first paragraph. I'll just read the second. It provides guidance for systems and architecture design, emphasizing human system integration. requirements and constraints. The third paragraph is basically describing the content, where we speak about life cycle, function, and location. As you would imagine, that would be 3 guiding parameters to a human spaceflight vehicle. The outcome should be in terms of guides or additional second, third level standards. And hence we are talking about a dedicated framework for specific vehicles. So for example, your company or your task is to focus on for example, government vehicle of specific form and function. This standard should be able to guide you and provide you with orientation in these in the related guides and standards for the design process, for certification, for conceptualization, and so on. And now I have about 2 slides or 3 slides about the nomenclature, which I have already mentioned is a core. It's really, I would say, almost more important than the standard itself, because we were attempting to not redefine the terms and definitions, but rather integrate them. So we were looking at different standards. You see over here that we are quoting ANSI, IEEE, ISO standards, the system engineering standard, ISO 15288 as well. And we were trying to look for common denominators and define or integrate, meaning put together the definitions from these standards in this S-153 standard. So we would have governing standard that does not deviate from traditional engineering disciplines, which are ahead of the architecture discipline in terms of standardization. And we believe that we succeeded to certain part or a certain scope. And here's an example where we are defining the architecture that fits, which definition fits to other engineering disciplines. There are further definitions like architecture classification, for example, which are not standard for, let's say, academia, for some industry or governmental organizations. But we found that quite important because this classification is helping the overall ontology. So in order to overview some ontology of some system, we want to have perfect state-of-the-art surveyed, basically everything what is out there. And based on our experience, we were also a team of transdisciplinary experts. We found out that, and I personally work with enterprise architecture, that the term architecture requires to be stratified into different types of architecture, because it is being used and it will be used in other than building domain. And it's been used for many, many years. It's just the fact that the individual domains are isolating themselves from others and trying to hit the market means that they are not usually aware of other disciplines using system architecture or architecture approaches or almost traditional like building architecture approaches. And so these 5 classes were identified throughout the research on this standard. We don't know if this is going to be finite list, if there will be any other scoping, but this is, for example, an environment that could cover the whole life cycle of any product, including governing systems. And that boils down to other definitions where you may know infrastructure, for example, term infrastructure. In space, the term infrastructure is used in many areas, including normative area. That means including area that defines standards, or that provides standards, or that guides standards, and that guides technological processes, material development processes, certification processes. So these, let's say, not the discrepancies, but different levels of language we try to cover in the nomenclature. So for example, infrastructure is not only technical framework or technological infrastructure of a deep space network for telecommunications or sharing data, but it's also the methodology or operational procedures. Last point on the nomenclature, which I wanted to just show you the again excerpt, because I cannot go much in detail, is on other terms. So when we speak about architecture, and I'm emphasizing architecture only because I was part of the Space Architecture Technical Committee, and I'm chairing the Committee on Standards, but there's many other terms and definitions that we have covered. And again, most of us may not be familiar with architecture method, architecting methods, architecture framework. What is architecture description? That the architecture description differs from architecture classification, for example. Further on, life cycle is a term that is very common in system engineering, which we have adopted for human spaceflight life cycle. So this is also very new to let's say industry domain or academic domain. Government, for example, NASA works with their own definitions, and they don't necessarily need to differentiate between human and product life cycle, human vehicle and product life cycle, because the prototyping is on such a higher level of commonality that they don't need to do it. But for individuals who seek for abstract, short, compact overview of the environment, this is very important. Also, space architecture. Interestingly, we had very heated debate on where that belongs in terms of terms and definitions. We agreed on custom or customary approach to space architecture definition as an informal term, and that will be definitely open to discussion. The reason for that is the actual use of terms space and architecture, because those space are non-ambiguous. So space architecture can be otherwise applied to traditional terrestrial environment. And again, standards try to avoid any confusion and ambiguity. So this is a huge topic for another paper or research or commonality analysis. And further on, of course, definitions of terms and hierarchies such as spacecraft, vessel, spaceship. How do you break down what is higher level, what is lower level? So we attempted to provide this tree as well. And the common denominator is spacecraft. And although there is a lot of strong opinions about what the spacecraft is, that is only robotic vehicle, for example, in some organizations. But in principle, we agree that spacecraft is the highest level common term that defines either manned or unmanned vehicles throughout the history. So I think that's another interesting point I can pull out from the nomenclature. So the actual content of the standard is touching these areas, and I will show you what is the structure, a very rough structure, very simplified structure of what the standard is trying to provide you with. And we talk about typology. Typology in terms of, for example, similar to automotive or building industries. We have, for example, vehicles that are up to 3.5 ton, above 3.5 ton. Then we have construction vehicles. Then we have special purpose vehicles. So we are trying to do the same in human spaceflight with spacecrafts. Similarly to in building industry, we have residential buildings, we have civil buildings, we have government buildings, agricultural buildings, and so on. Again, similar to human spaceflight. So we are trying to absorb this logical thinking we are using in different industries and apply that way of thinking in human spaceflight. So these categories are were were screened through with a number of subject matter experts. We have settled down on 8 categories that we believe that they are all encompassing in terms of the near human spaceflight future. Further, these categories are addressing life cycle, and I'll show it on the next diagram. In terms of scope, I received this question a couple of times. What is the scope of the standard? So there is no limitation, and we are looking into scope in terms of environment, where that type of vehicle will be operating, or what is the destination of for that vehicle, or how it will achieve its function in terms of place in solar system. So again, there is no limitation. We are not dedicating the standard to specific, planetary body. We are not dedicating it to specific orbit, but we are looking into this very generic and hopefully useful environmental applications such as suborbital, orbital, surface, and we are naturally breaking down these into higher level of detail. Here is an example, a very simple example. For example, my task is to develop medical facility on orbit, or orbital medical facility. And I am architect working for a small aerospace company that received funding to develop concept of this orbital facility. So for example, I look at the S-153, I look up orbital systems, then I look up medical facilities, or however the medical facility would fit in the 8 categories we have defined. And then I will look at the life cycle, at what phase I am at with my development. In this case, it might be concept. So I seek any standards, any guides that would be applicable for concept development of this vehicle. So the beauty of it is that this open framework could be complemented by other developing standards. So we are hoping that if other experts and other groups will adopt this framework, we would then easier communicate. And these are the questions you may ask when you are trying to place or identify yourself throughout this standard, your project throughout this standard. You can also accept the other approach or adopt another approach, and that really depends from which area you come. If you come from academia, you might want to start with defining these 3 domains and teach students on how they should already think about the topic before they got the definition of the task. For government, it could be interesting from perspective of, for example, classification of specific government vehicles and control and regulation of individual domains or individual vehicles by imposing, for example, specific safety standards and plugging them in this framework. The standard use also simple guide how to use it, so simple process flow and the links to the existing standards, which currently we have only few, and we are expecting that the update would govern many more. So there may be additional incentive to get the standard updated on regular basis. We are currently investigating how this process would be easiest to do in the fastest manner, since there are a couple of standardization organizations that are working in parallel independently. And I have attempted in the past to function as support for coordination, but since there are, this is very interesting, since there are industrial interests or personal interests, you may not necessarily get the perfect overview doing so in terms of the collaboration or inter-organizational communication. So this is something that maybe government could do or if the organizations find some agreement, standardization organizations find agreement that they could do it on this basis. But since also the standards are commercial domain, we may expect that there will be always a little bit of friction. So the easiest way to update the standard is communicate with government, follow up with what government is publishing. As recently, FAA published update on commercial spaceflight, so that update would immediately end up in this framework and the updated S-153 standard as well. And now I have only a few concluding points. Why we are working on this standard, or why we are working on other standards, as we are currently discussing different topics that may be standardized. And I assure you, there is a lot of knowledge, specifically on NASA public side, that could be standardized, but currently is not. So first of all, faster development on industrial level. That means faster development of technology, definitely enhancing and structuring education in human spaceflight. So these standards may significantly help in this area. Standards in general are compilation of subject matter experts' knowledge. So the process is very convoluted, but there is very many experts involved. So if you see a standard that was published, you should value it also for the fact that the number of experts got into agreement. So it is not, let's say, decision of CEO. It is not a decision of one person or a market necessarily that define that standard. And finally, AIAA and ANSI standards are unbiased of industry trends and needs to a large extent. So this is a statement. This is my personal opinion based on my experience. So I'm not quoting anywhere ANSI or AIAA. But because of this fact, they are more generally applicable. Other standardization committees may be biased towards some industries. It really depends how the standard is, for example, funded, or if it's unfunded, like we are a voluntary committee of experts. We are absolutely unbiased of industry. Our only interest is to provide faster and speed up technology development, as well as architecture education and overall governance and coordination. So you see the ISBN to the standard at the right bottom. It's available online if you are interested. And I'm definitely looking forward to any questions and hopefully also some collaboration, because we are currently a little bit on standby before paper publication for associated standards, and we will be reconvening the research and standard development process as soon as we settle on the potential topic, the most important topic.
Andre, thank you, Andre. Do we have any questions in the audience?
Yeah, I have a few if I can get my system together here. I joined just a couple minutes late, but in terms of the standards that you did look at or are maybe alluding to, did that include the IEEE, ISO, IEC? It's all getting very complicated. 2010?
Yes, we were looking into that standard as well. That was one of the difficult ones, but I think at the end we kind of found agreement on integration of primarily on the nomenclature side. So we actually do quote for 2010 number of times, including its UML diagrams, UML definition diagrams, which are extremely useful. And when I when I read the standard for the first time, and being my first degree is in architecture, I was stunned that this was not propagated from academia. That it should have been a long time ago. It's a long time overdue, and so this is another way to try to push it to general undergrads and master levels in system architecture.
Right. Overall, I think that's a fantastic idea to have this standard as it applies to space, to get everyone on the same page and talking about things the same way. Yeah, my background is architecture, and I'd love to talk more about some of the ideas and some of the things that I found make a difference when establishing frameworks and everything that is associated with that. And one of the things that for 2010 helps you do is establish a description of that architecture using a standard set of views, and establishing that standard set of views, I think, is something that helps people when they're comparing architectures to understand what the differences are and the quality of the work being presented.
Yeah, I completely agree. And again, I think that there should be much more awareness from ISO probably, or academia should better connect with ISO on this, or IEEE in terms of this standard, specifically this standard. We have a large number of quotes from that standard in our standard. So I don't know how else this could be done. But seriously, this is about taking the first steps and try to present, for example, the overview of the standard at University of Houston here, going further and go somewhere else. So kind of trying to populate the awareness, and this is a question of outreach. So the education is structured in the same manner. Because I recall I taught in two universities, and each of them had completely different approaches, and they were not usually rooted in standard or some common practices. And I have no clue why. Most often I kind of explain myself the reasons were because the industry was not interested to share their practices, but as a matter of fact, these standards are public. So another problem could be that the universities do not want to pay for the subscriptions, or they don't want to share it with students because it's a document that should be shared only with industry. So there can be a lot of background noise, background resistance. I'm, for example, not aware of. So this would be a task to the academic portion of our audience to look into it, whether this makes any sense, and, for example, structure the education according to these standards.
Yeah, no, I understand, and I've worked extensively with Dr. Bain at USC and at Vanderbilt as well, with the ISIS team over there. And it really has to be a part of their emphasis in architecture. And if the school doesn't specifically teach architecture, you're not going to find a lot of adoption of the standards. And those are usually graduate level courses as well. So the undergrads really don't get that foundation. And yeah, I understand it, and it's also a challenge when you have domain specific methodologies like the military that pretty much ignores those standards and has their own frameworks. And so that drives a lot of that understanding of architecture description, but that's for a very, very different purpose than what these kinds of standards should be striving for. But if you do end up with a Space Force project, for instance, then you'll probably be pushed into DODAF as a way to describe the architecture. And so you have to be aware of those things. But we found that while the DODAF, which is the DoD architecture framework, met the needs of the DoD to understand the work that was being done from a contractual and requirements standpoint. We did not think it was an adequate description, and so we went with the predecessor to 42010, which is what it's based on, an IEEE standard.
Mm-hmm.
Anyways,
well, when you just a side note here, because I did look into specifically the enterprise architecture integration with the systems and technical architectures, and we found actually common, I would say, denominator in the defense information systems architecture approaches, which stratifies, and this is one of the architecture classification definitions we introduced, which is a new, which merges the ISO, IEEE, and defense architectures. It does not eliminate anything. This is very interesting that they complement each other. It's just so broad scope that none of the disciplines or none of the domains are interested in covering it all. So if you look at our classification, we are integrating actually the defense information system architecture with traditional IEEE architecture classifications. But I know what you're talking about, and we were also discussing whether the enterprise architectures should be developed in higher level of detail. In this standard, we focused purely on spacecraft. So the enterprise architecture is addressed only from perspective of the nomenclature. We were really had a hard time getting more let's say people to agree on things. So really the spacecraft is the primary focus at the moment.
And the standards eventually evolve. Of course, it takes much longer than evolution of various ICDs interfaces and so on, because those are more unique to projects or programs. But it's definitely important to have standards in place, because it's much easier to point to a standard and declare that the program will follow those standards versus to go with the interface definitions. And it's those that are working in Gateway, Artemis, or just about any program know that it's very tedious. And I want to compliment your team, that was working on definition of the standards laying out, because it will be used by the whole industry, and it's definitely impact to a whole industry. Also wanted to take an opportunity, since Manuel joined us, that most, if not everyone, aware of the upcoming test. And I wanted to wish Boeing and the NASA team to have a successful test flight to International Space Station. We're all rooting for you.
Thank you.
Yes, Manuel is working on a Starliner.
Yeah. Things look great right now. And yesterday we had the mission dress rehearsal there at JSC, and everything went well. And we're just excited to get there.
Can't wait to hear the report next week.
Awesome. Wishing you best luck.
Thank you.
Any other questions, follow up on, I did see that Carolyn Conley had posted in the chat. I think she's still here if she wants to follow up on her comment, but also on the benefits of the standards, and that it's even though it is protected as far as you have to pay for to access standard, but it is $20 is really nothing. It's not like thousands of dollars, but the copyright does give a protection, so it's not easy to change, and therefore the adherence to the standards, and it's much easier to abide.
Svetlana, this is Carolyn, and you summarized that perfectly.
Thank you. Any other comments, questions?
I just wanted to say that I downloaded a couple of weeks ago and I was reading it. It's really impressive, and I wish I had access to this standard when I was studying at 6 but I mean, it's never too late. So it's really impressive, and I hope all the space architecture students or those who are really working, they at least get a look at this. It's really impressive. It's a really great job. Thank you.
Okay, thank you, Masa. And I just want to mention that actually the director of the SIGSA Space Architecture Program, Olga Banova, was one of our collaborating members. So she actually spent a lot of time reviewing and editing the document. And I'm sure that you would have access to it if the document would be published, but it was published just this May. So unfortunately, yeah, we could not speed this up. This is, and I wish that more individuals, subject matter experts, architects, system engineers would get involved in this standardization process to see how difficult it is actually to find common language and common structure. So at the first look, you may say, "Oh, these 5 categories, such a piece of cake. We could have defined it, or we talked about it." But finding a consensus on international level is totally different story, and that's what we attempted to do also through this standard. Not even talking about finding consensus with existing standards. So one needs to study the existing standards that relates to the same topic in different disciplines, in electrical engineer, in unmanned spacecrafts, and we attempted to basically link them all together. So, and again, I'm not saying we've done a perfect job, but it's a first shot, and I believe that this will be updated. Hopefully, it will be updated if it is going to be used. So I'm looking forward to future collaborations on this.
Yeah, sure. I'll contact you about that. But the good part of this main standard is that it gives us that big picture, that those diagrams, I mean, and they're really, I mean, I was thinking how many hours you spend on those diagrams to be this kind of accurate, and shows everything that, hey, if you want to start from somewhere, find your place in this chart, and then this is the path that you need to go, or you need to think about it like that. And I mean, I don't know, at least for me, this is a good roadmap that, hey, this is the, if you want to put your next step, this is the thing that we are thinking it's going to happen. So walk on these steps, or give us the feedback that, hey, I think it differently, and maybe we can think about it other ways too. But yeah, I mean, in my point of view, it's a great roadmap.
Excellent. Thank you.
Thank you.
Hi, Andre. It's Olga. Thanks for the presentation, and thanks for leading this effort. It was hard. It's always hard to manage a team of people with different opinions, but here, especially when you aim to have something common and have them all agree, it's difficult. But can you elaborate a little bit more on those next step? And when you talked a little bit about the next step and the most needed standard that will come up out of this one, this ontology generic one. Can you elaborate a little bit more? So what aspects you're considering? I know we talked a little bit before, but can you talk about it so people will know and probably will reach out to you if they want to collaborate on it? Thanks.
Yes, I mentioned a couple of times throughout the standard that the next step is basically to gather the feedback of the industry, academia, and government, and hopefully receive some feedback and try to integrate it in a newer version. The part of this update of this standard will also be additions to the framework that is already currently presented, additions in terms of references to existing standards. So as I mentioned in the presentation, this standard should point you at the relevant standards of the scope you are looking for. So for example, you have certain focus, you need the certification for spacecraft for, let's say, manned flights to a short destination or suborbital tourism. How will you proceed? So this information is already publicly available, but at the time we were working on this framework, it was not our primary focus to fill up the standards with the references. That would be work for the next years. Considering and knowing that standards come and go and they are being updated, there is additional incentive to look into the existing references we are using and look for any updates in other standards we are quoting. And so this is in terms of update. In terms of the need, now there are different needs. There are needs in industry, there are needs in academia. The ontological standard was supposed to provide like starting point, right? So we are investigating the need right now. I know very well that in the past there was expressed need at the Space Architectural Technical Committee for standard for a volume for habitable volume or volumetric standard, if you want. And that should be talking about how much of habitable space should we provide to crew or commercial spaceflight participants during spaceflight. And it's a function of, the result is usually a function of duration and many other parameters, duration and the size of the crew, or duration and function of the vehicle. And this is something that we are currently investigating. And as I was referring to NASA previously, NASA has published a lot of material, a lot of data about how the habitable volume should be evaluated, how it should be assessed, what are the best practices. So we will be looking into this public information. Again, we need to work with public information and investigate whether this topic is standardizable, on really standardizable in terms of providing some values that are generally accepted. The difficulty in this area is that the flown vehicles or flown vessels were usually prototypes. Almost every single vehicle was some type of Go ahead, Manuel, you wanted to say something?
No, I can.
Okay.
No, I'll mute.
So developing standard based on prototypes is very difficult and can be very tricky because we can miss the actual need. Prototypes often cut corners or do not have information required for standardization. That means some type of common practices, the best practices, empirical knowledge that is based on practice. So we are not knowledgeable enough at the moment, at least my team, that we would start developing volumetric standard, but it is possible. Further, we are trying to connect with broader community through upcoming publication to get reviews of this standard and introduce publication about the standard to public and gather feedback. So I think the most important part is currently the feedback. So we do have, I do have already some feedback from academia, and me as an academician in the past, I know that I would use that standard myself for education purposes, but we don't know whether government and whether industry will and how they will find it useful, and whether they will be willing to contribute to this standard as well. So those are, I think those are the next steps. We are investigating other topics as well for standardization as a committee, which are still being drafted and discussed only between me and Fred Swine, because we haven't settled down on any topic. And I'm still trying to understand a little bit better the need for specific topic. So should there be any suggestions, recommendations from our community, from the audience, please send it out. I believe you can contact me through the AIAA or I don't know what is the best way actually. Through the spacearchitect.org or through LinkedIn, you can find me pretty much anywhere.
Yeah, that
or engage,
actually
AIAA engage. Okay.
Right, and
Yep.
the question that I had, what is the form of the comments or input feedback would you like to receive? And I agree with Olga, probably AA engage is the best way to collect, because you by posting there a feedback, you can actually collect feedback from other members, because that would increase visibility and most likely will increase engagement of members that otherwise would not even pay attention to it.
Sounds good. I will ask Olga to guide me through that. I don't think I have ever done it before, but it sounds like a very good platform.
I can guide you too. You're welcome to.
Or you, Svetlana. Okay. Sounds good.
I do have one follow-up, Andra. In your discussion, I know it's not in the document because I just searched it, but in your discussions, did you ever think about architecture evaluation?
Well, that's a little big conundrum through which I'm going professionally every day. So yes, we are thinking about it in broader team every day, and it's very difficult. That's all I can tell you that I'm very certain about. I'm very certain about that evaluation is very difficult. There are teams at Johnson Space Center that are trying to develop standard evaluation matrices and evaluation methods and techniques for architecture. I think that's definitely something we would like to have, but if we don't have even the framework against which we are evaluating, we cannot even evaluate. So yeah,
that's one of the challenges, and the Software Engineering Institute has, of course, developed a very comprehensive evaluation methodology, the ATAMs, and that can be very heavy and very challenging. And we practicing software architects have developed more lightweight evaluation methodologies based on ATAMs. But I think that may be a subcommittee of this that you might want to stand up, and would be I think a good topic of discussion going forward.
Yeah, it's definitely it's a brilliant topic. It's a brilliant topic, but to tackle it, that may be more complex than actually drafting this ontology. I can see that again, software domain may be ahead of us simply because software architectures and engineering can be perceived as more structured than human system architecture that encompasses also the software and the hardware, and we always talk about physical and cognitive states of human. So there is basically too many variables. I'm not saying it's not possible. Definitely not saying that. I'm definitely saying that it's a beautiful topic for investigation, and there are attempts to do it from different perspectives. And now the question is which perspective we would take for the evaluation. for example, at JSC, there is interest in usability perspective. Now, that's another very soft topic that is very difficult to stratify into quantitative values. So although SAS is being used, how practical it is, there is too many methods, too many evaluation methods that are not useful. So they give you data, but you cannot make decision based on the data. You have just beautiful statistics. So now the question is whether you are gathering data for the evaluation or whether you are trying to enhance the development process. And those are, again, two different viewpoints. So,
yeah, and you may have heard of a concept of systems architecture. That was something that we developed as part of working some of the military contracts. But what we found is, regardless of the domain, you have to establish the beacons of the architecture. And you may have seen some mention of it in the IEEE standard, which is establishing the quality attributes. And the quality attributes are non-functional requirements, but that can help guide a lot of the basis for evaluation. Because at the end of the day, you really want to know, do you meet the quality attributes? Did you meet the intent of this architecture, the underlying system that you're trying to develop? And it could be safety related, right? We like to say all of the illities, like you just mentioned, all of the illities would be quality attributes. And the challenge with quality attributes is they need to have a basis. And many times they come up as an afterthought. Oh, what is this thing doing? Okay, well, maintainability, sustainability, safety, security, and all of these other aspects of the architecture, where we discourage, going back and filling in the illities, right? We want to say, what are the key performance indicators that this program is trying to achieve? And then from there, you establish the quality attributes, which are, the non-functional requirements that get overlooked over the functional requirements very consistently. And then even from there, I derive TPMs in all these areas where they're, obviously for functional requirements, you're going to have every program, especially space-based programs, have to meet their swap requirements and things of that nature. And then there's the non-functional requirements that you have to derive the the TPMs for. And if you have your quality attributes, which are based on something real and objective of the program, then you can more easily, methodically derive all of these very difficult things to correlate for non-software systems.
The topic you just mentioned very closely reminds me requirements verification process. So should there be architecture evaluation? That's what we basically do at the verification level, and we are doing it also on developmental level. The problem with standardization is, I would say, the very big difference in complexities of individual systems. So if I'll be evaluating a space station, it's going to be very different evaluation process to a space capsule, for example. Now, I understand that you would suggest there are always the same attributes you need to address, but they will be very broad. So it's going to be attributes such as safety, and then we deviate to certification process, which is the evaluation for us. Does it pass or not? And then there we are addressing this multitude of questions to pass the vehicle, the evaluation. But if you think this process should be done before, let's say, the developmental evaluation.
Oh, absolutely. We want to see the architecture. We want to see the architecture elaborated, and we would evaluate that architecture before a single line of code is written, but that tends to be, waterfall, right? We don't want to be waterfall and fall into that process. So we look for early opportunities to do incremental architecture evaluation as the system is being elaborated. And using some of these SEI methods for developing the architecture, you can do that incrementally, and then you're able to give that feedback into the architecture before it's developed or before it's matured. And trying to evaluate the architecture after the system is already coded, very, very, very difficult to correct it, right? You can say, well, you're going to get a race condition right there, talking about software. You're going to get a race condition right there because, the behavior of the system is such that you're never going to, be able to unlatch from the space station, right? And now you've got thousands and thousands of lines of code that are impacted, and all the, certification issues, their quality issues, and re-verification of that software. It's too late. Too late. Now you're just patching.
So from this perspective, in let's say a large space station architecture, we kind of need to define the granularity to which we would investigate the quality, and that's also a very open topic from my perspective, because if talking of, for example, the concept of spacecraft, talking of concept of lunar base, those are very large system, super large system, right? So you will have always a hard time and grasping the detail with, and that's what architects are for. They tackle the level of abstraction and concepts to put them together in some type of cohesive architecture concept. But how to evaluate whether it passes or doesn't pass, again, it seems to me that instead of very standard process, there might be this kind of evaluation in terms of requirements. Did we pass the requirements that the stakeholders or customers gave us? You know what I mean? So, and then could be a different level. Did we pass the traditional standards? For example, potentially volumetric or ECLIS or some other standards that require certain air of volume of air to be circulated. But in terms of evaluating the architecture itself, now I'm talking the technical side, the architecture itself, that seems like we could address it from perspective of inclusiveness. Did we include all these areas that should be there? And that's another thing that the ontological standard could help with, for example, because we try to be inclusive there. How the initial definition of the architecture framework happens. But then you have the comment that, all right, we are using a standard architecture that should not be used, copy pasted and used everywhere, right? So there are these two tricky points, to what level we need to go custom, to what level we need to stay on standardizable level.
You're already on track for a domain specific, right? A domain specific language. And that is another fantastic, topic for a subcommittee is, as you talk about UML and you talk about, other frameworks, there's the architecture description language and the avionics architecture description language. And these are in the realm of the domain specific architecture language. So you should have your own domain specific language as a result of this, which would be the space architecture description language, which would be based on UML. UML is always kind of the underlying, framework. And then these domain specific languages become profiles, right? The AADL profile, for instance, that sits on top of UML. And I've done a lot of work with Vanderbilt and on this topic of domain-specific modeling languages. And it's something that I think we, as a committee, architecture committee, you should also touch on.
Mm-hmm. This is a great point. I actually would not have, let's say, courage to suggest something like that because that may cause focus on one discipline. And what we were trying to do, we were trying to actually work with languages of our disciplines. So now the question is how do we tackle it? Because creating domain-specific language means that we need to teach the other domains the language and or at least respect that there is another domain that has its own language.
Yeah, let me give you an example. For the U.S. Army, we developed a domain-specific modeling language. All of that meant is that we incorporated that ontology and the taxonomy in our modeling, even though we did it in UML, and then we also did it in the generic modeling environment, which has a UML underpinning. All it meant was that we were able to talk about, battlefields, right? Battalions and the vehicles. This was a system of systems architecture, but we were able to have a consistent conversation, and that was not something that was foreign at all to the domain, meaning that anything dealing with Army doctrine and Army standards and the ontology used by the Army was included in this representation. So I think you're going to end up there because you've already defined an ontology, and it's just a question of who's going to be the grad student that takes on that domain-specific language as a basis, for their thesis.
Yeah, that would be great. Unfortunately, we didn't have any grad students this time, so I'm afraid that we will have to do it on our own. But thanks for introducing this topic. Because
I think I have too much time, but this is just my passion.
That's fantastic.
Yeah.
I would actually suggest to tackle this and discuss it in SATC as well in the SACOs, because I think the domain-specific language, I would try to create non-specific for space architecture, meaning that we would work with languages from other domains. That would be maybe different approach, but I think it's something that architects would desperately need, because they may tend to be isolated in the environment, and I think they should be rather connecting the other domains than creating other let's say kind of niche terminology. And we found pretty much everything in the IEEE ISO and these standards, so or IEC as well. We just needed to add to it sometimes human factor component, sometimes big picture kind of perspective, and sometimes basically common practices in architecture. So it kind of appeared to be that the founding and building components are out there, they're just not connected. And that was kind of interesting learning from developing this ontological standard.
Great work.
Okay, thanks again for those points. I have noted everything, which will be in workings in terms of what will be the next steps of the committee. Thank you very much, Manuel.
You're welcome.
Okay, any other questions? Thank you, Manuel. That was a great discussion, and definitely points that the whole team into a right direction. So if there's no follow-up, thank you, Andre, for presenting this. It's a very important and timely topic for a lot of us working in the space exploration industry. I wanted to mention that we have scheduled speakers for August 7th and August 21st. And in between, we will have a free-form discussion. every Saturday, as I mentioned, 8:30. This forum is open. You have a link. You are welcome to join. You don't have to make a reservation or registration. And we will continue discussion about this topic and others. And I am looking forward to hear the successful flight report from the Starliner test next week. Can't wait. We will be watching.
Yeah, hopefully I can join and give you the update.
Absolutely, looking forward to it. And if not next week, then the following weeks after that. Absolutely. So with that, thank you everyone for joining. Thank you, Andre, especially for your presentation. And we'll see you next week. Have a great
Thank you for the invitation. Have a great weekend. Bye-bye.
Bye-bye.
Thank you. Bye.
Thank you.